of the class. All right, well, thank you for joining. Today we are going to talk about sedimentary rocks. All right, so the lesson is here on the unit of geology. Last time we talked about igneous rocks. So today we are going to talk about sedimentary rocks, and next class it will be about metamorphic rocks. Do you remember from last time roughly about how much, if we consider the total volume of the Earth's crust, okay, what were the percentages between igneous, sedimentary, and metamorphic, okay? About, considering the whole volume of the crust of the Earth, which ones were the most common? Igneous, sedimentary, or metamorphic? What were the percentages? Do you remember that? You can either open the mics and say it on the mic, or you can write it in the chat, whatever you prefer or remember. Hello, Sabrina and Alex. Okay, Haley says, I don't remember. All right, well, that's a fair answer. Okay. So let me go really fast to that. Let's see if this will take us there. Okay. So sedimentary rocks. What do you mean, Ben, by saying sedimentary rocks? Mm-hmm. Okay. So I don't know if you remember. Apparently you don't remember, but okay, I kind of remember. So the most common, okay, let me see if this is the article that goes to that. Okay, so the Earth's crust. Okay, so we have, okay, here, let me increase the size. And so composition of the Earth crust, and here we have the different elements that compose the Earth crust. It doesn't say, this wasn't the article, it was the Earth's article that had that. Okay, here, this one, let's see if we can find it. So here on the article about the Earth, and we go here, the section of chemical composition, all right. It was talking about all the different elements that compose the Earth, okay, the tectonic plates and everything, the geology, okay. There was one place here, let's see if I can find it here, igneous, okay, all right, so let's see. Okay. No, it wasn't over here. But there was one part where it says that basically igneous rocks compose about 2/3, about 64, 67% of all the crust of the Earth. So igneous rocks are really the more common of all the rocks. Then you have sedimentary rocks, okay, and here in this article it says the total contribution of sedimentary rocks is estimated to be only 8% of the total volume of the crust. So sedimentary rocks are not that common. It's 88% only, okay? So as far as the total volume, you don't have a whole lot of sedimentary rocks, but are they common to see? Are they easy to find, sedimentary rocks? Or are they difficult to find? What would be the so we have that as far as the percentage, the volume, you have igneous rocks are the most abundant, then metamorphic rocks, and then sedimentary rocks. Sedimentary rocks being only 8% of the total rock of the crust. Okay, but which ones are easier to find and why? How would you put them in order between igneous, sedimentary, and metamorphic as far as easiness to find? What do you think? You can write them in the chat in the order, okay? So you could put, igneous, sedimentary, metamorphic in order of from easiest to find to hardest to find. Okay. What do you think? Hello, Mac.
I want to say that it would be igneous, then metamorphic, and then sedimentary.
Okay, sedimentary being the hardest to find in your your estimation.
Yeah.
Okay. Any other ideas? Any other suggestions? Why do you think that? Why do you think that it would be igneous, metamorphic, and sedimentary? That is the same order of the abundance. Okay, so is that why you would think that they are in that same order because of abundance?
Well, mostly because metamorphic rocks are, created by heat, I believe, and it makes up, I believe, like a large part of the Earth's crust. So I would think it would be metamorphic before sedimentary.
Okay. As far as easy to find, okay. All right, good guess. So actually, all right, as far as easy to find, the sedimentary rocks are the easiest to find. Okay? Because most of the surface of the Earth is covered with a thin, sometimes thick, but sometimes it's just a thin veneer of sedimentary rocks, sedimentary deposition. Okay. So the rocks that you find usually, just lying around, okay, on the surface, all right, and we are going to see how you can recognize them. A lot of those are sedimentary rocks, okay. So sedimentary rocks are probably the easiest to find. Then igneous rocks are also very easy to find because they can happen through volcanic activity, and so they are also on the surface, or you can see them on the side of mountains, as mountains are uplifted, and because they are hard, they don't erode easily. Okay. And then the hardest to find are actually the metamorphic ones, because the metamorphic ones, like you were saying, they are produced with heat and pressure, and so usually they are produced when they are covered, when they are underneath layers of other rocks. Okay, so that is kind of how it goes. So sedimentary rocks, by definition, are types of rocks that are formed by the deposition of material at the Earth's surface and within bodies of water. Okay, and here the article explains, how that sedimentation occurs. Okay, go figure. So as far as yes, Emma says so. As far as easiness to find is sedimentary, igneous, and metamorphic. Okay, so sedimentary is the less. Okay, only 8% of the total volume of the crust is sedimentary rocks, but they are easy to find because they are on the surface for us. Okay. So, and sedimentary, see here how it says, sedimentary rocks are only a thin veneer over a crust consisting mainly of igneous and metamorphic rocks. So, sedimentary rocks are formed from the erosion and then deposition and sedimentation of igneous and metamorphic rocks. Yes. Someone was having a comment?
I did.
Go ahead.
Have you been able to figure out why the GoToMeeting keeps stuttering or freezing for a second there and a second here? Have you been able to figure out why it does that?
Not really. Not really. I'm trying now to try to not have as many things running as possible, the least amount of things that I can. Okay. So was it is it better than yesterday, worse, or the same as yesterday?
It's always the same.
It's always the same. So it has to be something with my computer also. Okay. I'll need to troubleshoot this. So I really apologize for that. Okay. So let me address another thing. Okay. One of you, okay, was saying, so in the lessons that I have, okay, I always put, let's see if we go here to the lessons, I put links there to videos and to lots of articles, okay. Most of the articles they are on Wikipedia, okay. And one student was actually saying, the problem that I have is that when I read these articles in Wikipedia, I can only understand 50% of what it says. Okay, what do I do? All right, have you had that problem also? That sometimes, I send you to these resources online and you're like, I don't understand a whole lot of this. All right, Mark says the same. So you probably have a similar experience to that. Yeah. So let me tell you how to read these articles. Okay. So I think that this is an important issue. All right. And and it's actually a good thing, really. Annika says, when I don't understand it, I read more or look it up. That is the right strategy. So I have to tell you, when I read these articles in Wikipedia, especially many of these articles, I understand probably about 50%. Okay? Does that surprise you? Did you think that I understand everything? Okay. So Annika says more research, more knowledge. Christopher says that's what I do. Yeah. All right. So Rodney says no. You didn't think that you thought that I understood everything. No, I'm learning. I'm learning the same as you are. Okay. And so, for example, when I grab a topic here, I prepare for this lesson on sedimentary rocks. Of course, I go to this online encyclopedia that is beautiful and I start looking and finding for things. Okay. And so, For example, I started here with Sedimentary Rock article. And then I start reading. When I don't understand something, or when I think that I'm not getting something, I click on the link to get more information. Okay? So most of these articles in Wikipedia, they have an introduction, and usually the introduction is pretty easy to understand. Okay? That is probably the first part before this table of contents. That is actually the easy part to understand. So I read that carefully. I try to understand that. If I find that there are some links or words that I don't know, I click on those and I try to understand those. Then I go through the table of contents and I start reading and looking for the things that I find interesting. All right. So you keep, there are some things that I skip over. All right. There are some parts that I say, I'm not too interested in that, and just keep going. Okay. But the important thing is to actually know what you do know and know what you don't know. Okay? Emma says, I also find writing it out helps, or saying it out loud, for me at least. That is a great idea, Emma. You know what I do is when I'm studying, I'm always thinking, how would I teach this to my students? Of course, that I have to teach it to you. But you can also think, could I explain this to my younger brothers and sisters? Okay? So, Manika says, I figure you did what my humanities teacher and I do. Look for things that are relevant and research things we don't quite understand. That's right, that's what I do, So, Max says, that takes too long. Well, what do you want? Okay, there's really no shortcuts to learning. We either learn with understanding, okay, I cannot pour knowledge into your brain, okay, so it is a matter of time and dedication, but it actually is a fabulous experience, frankly, all right. So what I did, for example, here is I was reading this, getting information about the different types of rocks, okay, clastic sedimentary rock. I would have clicked on this link. I haven't actually, so I don't know exactly what clastic means, okay, but we'll leave that to some other time. But I kept reading and finding, okay, that the sedimentary rocks are classified depending on the size of the particle that makes the rock. Okay, so see this part, it says clastic sediment, and that clastic sedimentary rocks are subdivided according to the dominant particle size, the diameter. Okay, and so we see that gravel is greater than 2 millimeters in diameter. Okay, so if you have gravel is stones or loose rock that is greater than 2 millimeters in diameter. Sand is between 1/16 and 2 millimeters. Okay, I can get that, I understand that. So now I know what is gravel, what is sand. Mud, okay, and mud is divided into clay. So clay is less than 256 millimeters, really, really small. And silt is between 1/16 and 256. So if I were to put them in order from size, I say, okay, gravel, sand, silt, and clay. Oh, okay. So that is how the rocks are classified. So this is the loose unconsolidated sediment, there's three fractions, okay? So gravel, sand, and mud. And mud is clay or silt. Can you see how that makes sense now as you read it? Okay, yeah, that makes sense. Then it says, the classification of clastic sedimentary rocks parallels this scheme, all right? So it follows, parallels means that it's kind of the same, okay? It goes together with this scheme of the size, all right? And so you have conglomerates and breccias are mostly made of gravel. Okay, all right, so now I can see that sedimentary rocks that are made of gravel with very, thick conglomerates, okay, they are called conglomerates and breccias. I still don't know what the difference between these two are, but I can find out, okay. Then I keep reading and I see sandstones are made mostly of sand. Okay, well, that makes sense. Mud rocks are mostly made of mud. All right, that's easy. Okay, so, and now I can find that they keep talking about conglomerates and breccias. So, what is the difference? That, oh, I have here a subdivision of that, and it says conglomerates are dominantly composed of rounded gravel, and breccias are composed of dominantly angular gravel. Oh, okay. So whenever I see also links that are repeated quite a bit, like conglomerates, breccia, sandstone, and mudstone and so on, then I click and I go and study more on those, all right? Now I can see pictures of those. Okay, now I can see that. All right, this is a very good example of a conglomerate. They are rounded rocks cemented together. Okay, that is another picture of a conglomerate. Okay, yeah, I can see now what a conglomerate is. If I go to the other article, let's see breccias. Okay, so breccias are composed of broken fragments of minerals and rocks cemented together. And it says, can you see now the rocks here, the conglomerates or a breccia, are not rounded. So these must be breccia. So the difference is in the shape of the conglomerate. Okay, can you see that this is not a rounded rock, that is angular? Okay, so that is the difference between a conglomerate and a breccia. Is the type of rock that makes them up. Okay, good. But you see, that is the process that I go through to learning these things. Then we go to the article on sandstone. Okay, these are more familiar to me. All right. Anika says mud rocks are made out of mud. Go figure. Unlike the tenerucites that do not have cell walls. In Spanish, that means to have. Okay. Do these types of rocks take a long time to form? Yes, they actually do. They do take a long time to form because of the process by which they need to be cemented together, okay? And that is what we are going to talk about. Emma says hundreds to thousands of years. That's right. So these are in geological times, and they are constantly being formed. Madeline asked, do all of them take a long time? Meaning all the different types of rocks? So igneous rocks, they are formed. Remember that we had the igneous rocks. We were talking about the intrusive rocks that happen inside the earth, okay, inside the crust of the earth. So you have the surface, so the igneous rocks form when the magma comes up and then it cools down slowly. So those take a long time to form. Then you have the extrusive igneous rocks that are the ones that come out of volcanoes and cool rapidly. Those actually take a lot less time to form. Once you have the igneous rock erupted, it cools down rather fast. Okay, so it doesn't take too long to form those. The metamorphic rocks we are going to see next week, they take a long time to form. How about the sedimentary rocks? What are the processes actually then for creating a sedimentary rocks? Emma says they have to be compressed, compacted, and cemented. So I would assume it would take some time. Yeah, that makes sense. That's right. So let's see what does it mean to go through this process. Okay, so you can read the article here on mud rocks, and you can see that the mud rocks are basically very, very compacted layers of mud. They are solid, okay, but they are compacted layers of mud as they go together, okay. Shale is another type of sedimentary rock. So shale is a fine-grained clastic sedimentary rock composed of mud that is mixed with flakes of clay minerals and tiny fragments, silt particles. Also, so shales are mud that has both clay and silt mixed together. And the characteristic of the shales is that they happen in layers. All right, let's see if we can increase the size of this. Oh, this is not a very good picture, but you can actually kind of see the layers of these sedimentary rocks, okay, that are still composed that way, okay. Good deal. We also have oil shale. I was curious about that, and so I opened the article there on oil shale and what is the difference between one and the other. The difference is basically that the oil shale not only has shale, okay, the mud and silt clay mixed together, but also has an organic rich, fine-grained sedimentary rock containing kerogen, okay, a solid mixture of organic chemical compounds from which liquid hydrocarbons called shale oil, okay, can be produced. And that is different. The shale oil is different from the crude oil. All right? So that is the oil shale. So you have a shale rock together with organic chemical compounds and materials that produce this shale oil. Abigail says, we have a lot of shale around here, and when I'm riding my horse, I can hear it underneath the dirt. And it sounds hollow. It's so cool. That's right. Why do you think that it sounds that way under the hoof of the horses? Christopher says there is a lot of shale by delta. The shale has a ton of fossils or of trilobites in it. Excellent. That's right. Abigail says, yeah, one time I was riding with my trainer and she found a huge shark tooth in the middle of Colorado. So the fossils also are a way to tell us about what was there in the past. So the shark tooth, the trilobites are all evidence that all that area was actually before time, a long time ago, underwater. And so the remains of these things also get mixed, okay, and get decomposed and everything and form shale oil, rock, and fossils of different things, everything. That is, but you can see the construction of these sedimentary rocks. Really interesting types. So now we have had, we talk about breccias, conglomerates, sandstones, mud rock, shale, oil shale. The oil shale is starting to get into the organic type of rock. To well in Utah. Yeah, that's right, Anika. But now let's switch a little bit and talk about limestone. Okay, so limestone is also is a sedimentary rock composed largely of minerals calcite and aragonite. So if I want to know more about what calcite and aragonite is, I would go and click on those links. But let's keep reading a little bit. So it says, which are different crystal forms of calcium carbonate. Oh, okay, so limestone is made of crystals of calcium carbonate, and I have here the formula. Do you remember in the previous class when we were talking about igneous rocks that they are formed mainly of the building block of silicon, okay, the silicates, okay, that are silicon and oxygen. So the carbonates are mainly built out of carbon and oxygen. Interesting. Most limestone is composed of skeletal fragments of marine organisms such as coral and foraminifera. I have never heard of this term. Okay, I have no idea what that is, and so I'm going to click and see what foraminifera is. Okay, so I think that it says they are a class of amoeboid protists. So okay, so these are very, very small organisms. Okay, so very, very small. It's type of plankton. Okay, so I'm probably going to find a lot of this, and so the remains of these organisms form limestone. So this is an interesting thing because now we can see that limestone is different from the sandstone, the conglomerates, the breccias, the shale. Those are made out of silicates. Okay, those are made out of, most sandstone is composed of quartz and feldspath, which are igneous rocks. I remember from last week, where limestone is actually made of calcium carbonate and is the remains of marine organisms. Very, very interesting. So now I know a lot more. So Christopher asked, aren't stalactites and stalagmites made out of limestone? Yes, Stalactites and stalagmites are chemical rocks. So what happens, as I was reading this article, okay, I found that, here we have a description of that in the article of limestone and everything. And then I found important information about where to find limestone. Okay, so, and you can read this in detail, but it also explains that limestone is used in building as a building material, but it's also in caves. So most caves are composed of limestone that is actually eroded. So you have a cave, and the cave is filled with limestone, but before the limestone gets cemented together, water seeps through and starts eroding and making holes basically in the rock and leaching the minerals out. And many times when they leach out of the roof, they form the stalactites, okay, the ones that are going from the top, and then they drip down and they form the stalagmites, okay, forming up. So all these very, very fragile are formed by limestone deposits that are leached and moved together, okay, over time in caves. All right, so that is very, very interesting. So Emma says like speleothems stalactites. Yes, yeah, and so we have seen three different types of sedimentary rocks. We have seen sedimentary rocks that are just formed by the position of rocks, and they cement together, okay, like the sandstone, the mud rock, shale. Then we started seeing some bio-organic rocks like oil shale and limestone. And then we also saw some chemical produced rocks that are these stalagmites and stalactites. All right, so you can see the different processes of how the sedimentary rocks are formed. Okay. Are you okay? Any questions so far? So I'm going to talk about now about how does the process of cementation happen. All right. So we talk about that these are rocks put together, but how do they happen? And so I read this article on cementation. All right. And it's very, very interesting. I'm going to let you read it. But I found actually that in this part, okay, after the classification, here, this part was actually easier to understand. The diagenesis. So what is the starting process of these sedimentary rocks? Okay. And so see how these sentences, young sedimentary rocks, especially those of Quaternary age, the most recent period of the geological time scale, are often still unconsolidated. So Madeline, you were asking how long do they take to form? So you see that the young sedimentary rocks, the ones that are still in this geological period, that is actually, quite long, are still unconsolidated, so they are still not totally rock together. They are still break apart. They are not completely cemented together. All right. So as sediment deposition builds up, the overburden or the lithostatic pressure rises, and a process known as lithification takes place. Okay, so remember that I was telling you I know a little bit of Greek, okay, and so lithos means rock. So whenever you see lithostatic, lithification, that means related to rock, okay. So the idea here is that, and then it goes and explains the process. Madeline says, so they are hooked together but can be broken because they aren't compacted yet, right? That is correct. That is absolutely right. So let's see. This graph is actually pretty cool, and it shows the process of cementation. So what happens is when the particles are young, basically when they are just deposited together, be it by water or air, the particles are not hooked together. They are just laying together, okay? But they are not yet together at all, okay? There is a lot of space between the particles. Now, what happens is that usually there is pressure building up because there's more particles on top. So these arrows here indicate that there is pressure building up between the particles, and so the particles are being squished together. Okay. Rodney asked, has anyone ever been to a cave where this is displayed? Yes, so I've been to the Timpanogos cave here, and that is awesome. That is a great trip to do. All right. So another thing that happens during this process is that usually water seeps, underground water seeps between the particles. And the water starts kind of dissolving the outer parts of the minerals between the particles. And then together with the pressure, you can see these same particles here, how now they are pressured together, the minerals are dissolved, they are built up, and then the particles start getting cemented together. Can you see that? The interparticle space is now a lot smaller. There's still water that can go through this stone, but now is a lot more cemented together. Okay, and so this is the process of cementation, that both between the pressure and the minerals that get dissolved and get closer together, they cement the particles together. You can see why this process takes a long time. All right, so sedimentary rocks are connected by pressure, but they still have bubbles in them, so the air bubbles make the rock weaker and crack easily. That is correct. So the same process that makes the sedimentary rock stick together, okay, that cements the rock together, is also the process by which in the future the rock can crack apart. All right. Okay, Madeline says, makes so much sense. Excellent, I'm glad. Can you see how long this process would take, Madeline? Can you see why it would actually take a long time for this process of cementation to be completed? So, because the minerals need to be dissolved and recrystallized, so here they need to be recrystallized together in order to be fused and fuse the particles together. The same here in these areas. All right. Now, as Emma was saying, there are still bubbles or space between, they're called pores. Okay, so let me, pores, all right, between the spaces. Water can still seep through these pores, and then by the process of cooling, and or freezing and heating up, or the process of eroding more of the minerals, they can break the rock apart. Okay, so it's really interesting to me to see that the same process that forms the rock can also break it apart. Here we have an example of a sedimentary rock, and we see the layers of the different sediments and the banded iron formation. So these red areas are areas where you have more iron mineral build up. Very beautiful sedimentary rocks. Okay. Madeline says, I wouldn't have enough patience to study this because it would take forever and you would just need to wait until the process is complete. That is why we study it instead of just observing it. That is a good point. Okay, so now we see how that process of cementation, and by the way, this process of cementation happens in breccias, in conglomerates with larger rocks. Okay, you see also how here the minerals are in between, and usually they are mud or sand particles that are together with the larger particles, but they are all cemented together. And the sandstone, okay, the same process and how sandstone happens. The mud rocks, the same thing, shale, and even the limestone, the organic rock, is also formed the same way. It's also cemented by these same processes. So we have kind of the same type of formation done together. In the lesson, I found this animation, all right? This animation shows here how it rains in the mountains, and so that is the process of erosion and weathering. The sediment is carried down and then is deposited, and then you have a layer of sedimentary rock being built up on land and also on the surface, okay, on the subsurface of lakes or oceans. So that is where sedimentary rock gets formed. All right. Let me see. I have also this. Oh, this is a very interesting website. I have the link in the lesson for you. And it has a very cool animation here of the process of compaction and cementation. So you can see now the sediment grain, all right, being whether it's sand or gravel or mud, silt, clay, whichever it is. In this case, this picture shows sand grains, all right? And then there's water in between, filling the pore spaces between the grains, okay? And that starts compacting with pressure, okay? The water taking away space and everything, it makes the particles be pressed together and they start contacting, they start pressing together. There's less pore space between the grains. So this is the process of compaction. The grains are packed tightly. Good. Now we know that. Oh, now we have the cemented sediment, is where the minerals around reform and form crystals around the grains. So now the pore space is very, very small, much reduced, and now we have recrystallized minerals joining the particles together. Okay. One critique that I would have to this animation is that here you have the particles touching each other, okay? I guess that the reason why they don't seem to be touching together is because the minerals kind of recrystallize and reform, okay, around it. All right. And now here we have a kind of a specimen of sandstone on that. So you can use this animation to explain also that process of cementation. I found this picture of the image of the Grand Canyon. So let's see, before we go to there, let's visit some places where sedimentary rocks are in abundance, okay? Do you have any ideas or suggestions of places where we want to go here with Google Earth? So if you have any ideas, just type them there in the chat. I would like to take you to one place very close to us here. Okay, it's in the Salt Lake. All right. So this is a satellite image of the Salt Lake, and all the areas that are white are evaporative sedimentary beds of what is called halides. Okay, that was a term also that I just learned. Okay, the halides are basically rocks formed of evaporation of water deposits with salt. So halides are rock salt. So all the whitish and white areas, all the salt flats of the Salt Lake are sedimentary deposits of salt. All right. Superman says, how about Moab, Utah with all the red rock? Let's go to Moab, Utah, all right, and see some of the red rock formation there. Okay, so in fact, let's go, close there to Moab, Utah. Let's go here to the Grand Canyon. Okay, so I'm going to take you there. There's kind of a place already here. All right, so it's similar, it's the same formation. They are in Moab, is the Moab and the Grand Canyon are just further down the Colorado River. And it is very interesting that here in this canyon, the Colorado River has made the erosion of that and exposes all the different layers of rock. Very, very beautiful formations, and you can actually see with the different colors, the different angles show the different types of rock that is being eroded. So the looser the rock, the more vertical you have, all right, because it erodes faster. The slope where is shallower slope, it is harder rock that is eroded at a slower rate. Does that make sense? Okay. So I have here, let's see, over here a little cutout of the Grand Canyon. And so we can see the different types of rock that are from the top to the bottom of the Grand Canyon. And we also see here the scale of time, how long it takes for the different types of rock here. So on the top of the Grand Canyon, we have limestone. What was limestone? What was limestone formed from? What type of sedimentary rock was limestone?
Limestone.
Yeah, go ahead.
So, I have a delay on mine. So, when you said it was limestone, I said my answer, and then you talked about it, and then it got to you. So, I'll just leave it at that.
What did you say? Repeat it because I didn't hear it. Mm-hmm.
I was made from water running. Layer is created because river and ocean is going over for a long time.
Excellent. Yeah.
So minerals going to.
Yeah, and limestone, we remember that it was one of the organic sedimentary rocks. Okay, it's formed from the skeleton. So see, the thickness of that shows the amount of time that all that had to form. Okay, so this was a long, long time of all this area being underwater. Okay. Emma says limestone is formed by calcite and tarragonite. Excellent. So it's organic type of sedimentary rock. Then we have composite rocks, okay, like conglomerates and breccias. Then we have here another layer of sandstone, okay, and then shale, more composite rocks. This one is another layer, it seems, of sandstone or limestone, depending on the color, all right, very, very thick. Another layer of shale, another layer of sandstone, and then composite rock, the bottom part, okay. So there are several images that you can look and see of this type of formation, okay. So we have also another example here with more of the different names that they have given to the different groups and formation of limestones, okay, shale, sandstone, and so on. All right. So now you can see this shows kind of the history also of all these layers of rock and what were they formed by. Okay. Let's see, let's go to another place. Any other place that you want to visit that has sedimentary rocks? So we saw the Salt Lake. Okay, let's put that upside down. All right, let's see. How about Provo Canyon? Okay. So in Provo Canyon.
Yeah, let's go there.
So in Provo Canyon.
I said, yeah, let's go there.
Okay. There is a tonto layer, yes. Yeah, that is how it's called. It's the tonto layer. So in Provo Canyon, what I have seen is a lot of shale. All right. So these are the layers. You can see a lot of layers of rock. Okay, let's go into it really. So this is Provo Canyon right here. Let me move this. Yeah. Can we see there is any in Texas, in Rockwall, Texas? So in Texas also you have some formations. All right. So let's see over here. There are some layers in Provo Canyon where you can see the banded of the rocks, okay, cemented together, and they break quite easily. Okay, let me go over here to Rock Canyon. Let's see if we can get a little closer to see that. Okay, so this is Rock Canyon, and over here you see on this side of the canyon the rock breaks quite easily. So it's younger sedimentary rock. Remember how we were saying that it's not totally conglomerated, not totally cemented together. And that is one of the problems why many times people die here in these mountains, because they tried, okay, this is Rock Canyon, they tried to climb these mountains and the shale breaks apart. So you see over here, these are very, very loose rock, not very well cemented together. So if you ever go rock climbing, you have to be careful to understand what is the type of rock that you are climbing in. Because if you climb on sedimentary rock that is not cemented together, it would break and you would fall. Okay, so you have to be careful. Annika says there are granite layers in New Hampshire, and here in Bolivia there are layers, but I don't know if they are different types of rock. So I want you to find out.
I think we should go to Maple Canyon. It's right next to Wales, Utah, and Canada.
Maple Canyon, let's see, Maple Canyon. Okay, Utah. Let's see if it finds it. That is another way of traversing. All right. Okay, so here we see these bands here. Is this the place that you were talking about, Rodney?
Zoom up closer.
Closer or further?
There's a lot. It's a really good place to free rock climb because the rocks have been cemented together.
Oh, okay, okay. So if the rocks are well cemented together, they are either igneous rocks, okay, they are intrusive igneous rocks, or they are well-cemented sedimentary rocks. Okay. So I'm not sure. All right. So here, what I can see, because I don't see a whole lot of horizontal layers in the rock, I think that these are probably igneous rocks. Okay, that have been weathered and washed. Okay. What do you think, Rodney?
Can you find whales first?
Whales?
Look for whales first. Whales, yeah.
Whales, Utah.
Whales, Utah.
In
Utah, there's a place.
No, I don't think that is the place.
That is not the place.
That is not the place, obviously. Let me go to another place, okay, that I think that it would be interesting. All right. So Max says go to Rockwall, Texas. Okay, I want you to go to Rockwall. Okay, Rockwall is the place where Mac lives. Okay, and it's interesting because Texas is very flat, but that particular place has actually kind of a layer of rock wall. You know, it's kind of like a side of the mountain that is wall. Notice this is in Bolivia. This is close to where Annika and Sam live. Okay, and La Paz is here. This is the capital of Bolivia where Annika lives. And we have very, very high mountains. See the elevation of La Paz. I don't know if you can see there at the bottom of the screen, but it says 13,242 feet. Okay, that is higher than the highest mountains here in Utah. Okay, so that is the bottom of the valley floor in La Paz. Okay, so that is the area there in La Paz. And see this area, huge area of a salt evaporation point. Salar de Uyuni Desierto. Okay, so this is a desert, all right, of sedimentary rock of deposits. Okay. Let's see another area that I wanted to show to you is the famous part in England, the cliffs of Dover. Okay, so these are famous because they are limestone cliffs. Okay, so let's go in. And it goes right from the English Channel. All this white side of the rock are limestone. So, you know, and see the elevation. It goes 62 feet, okay, or it would be sea level. And then it goes all the way to 350 feet, right there. So all these are cliffs, and they are all made of limestone. So the British... So
does that mean that the stone is growing each time the wave hits it, or is it washing it away?
Sorry, what was that?
Since it is limestone, does that mean that it is growing each time the waves hit it, or is it eroding because it's limestone, it's made from water running over it?
That is a good question. It's actually eroding. Okay, so at this point, the islands are not growing anymore. All right, but what this indicates was that Great Britain, at some point in time, it was underwater, and all this limestone was being built up by these organic microorganisms and coral. And then the island was uplifted, okay, and now it's basically being eroded from the top by rain and water running, and then from the bottom by the waves, okay. So there are areas where the rock is forming and other areas where the rock is being eroded. Very, very interesting. Great questions. Great questions. Okay, here let's see some pictures, okay, of rock climbing. Wow. See this picture here. All right. Oh, let's see. That is too close. But what type of rock would this be? What would you call this? And let's see this other one. Okay, so this is Maple Canyon. Okay. All right. So clastic, yes, it's clastic. And I would call this a conglomerate. All right, because you see they are rounded rocks, large particles cemented together. Okay. So, Rodney, have you been rock climbing here?
No, but I have been hiking several times up there.
In that area. Okay, so that is a good example of a conglomerate rock. So Annika says it looks like the rocks here. All right, so it seems that the rocks that you have there in La Paz, they are probably also this type of conglomerate sedimentary rocks. That they are cemented together. Okay. So the breaking apart is the process of erosion and weathering, and then the cementation is what makes the sedimentary rocks stick together. Okay, let me finish. We need to finish. I'm going kind of overtime here. Sorry for keeping you this long, but it's interesting to note that when the pioneers came here to Utah, they started building the Salt Lake Temple out of sandstone because they were able to find a lot of sandstone here. And so Annika says, they don't look very secure, especially when there are collapsed houses on top. Okay, yeah. So, yeah, you need to be very careful if you go rock climbing on conglomerate rock. Okay, you have to understand what you are getting into. Okay, so yes, if you need to go, you can go, all right, of course. But what I wanted to let you know was that when the pioneers started building the Salt Lake Temple, they started with sandstone. And then they realized that the sandstone was actually going to break from the weight on top of the building itself. And so they had to dig out the sandstone foundation, and then they started cutting granite in Little Cottonwood Canyon, and they made the whole Salt Lake Temple out of solid granite, igneous rock. Okay? So the igneous rock, the granite, doesn't have the breaks, the weak spots that the sandstone would have. And they spent 14 years from the time they started until the time that they were able to replace the foundation. Okay, 14 years of work that they had to redo because they chose the wrong foundation. What do you think about that? Okay, so that is interesting. So Annika says that
sandstone's really soft.
yes, sandstone is really soft. It can look cemented together, but the problem is that you always have those micropores in between. Say that again, Rodney. Say
your
that.
Your hand can brush, so just your hand, that force doing that.
Yeah.
Also, if it gets hot, it cracks.
That's right. That's right. And so pressure, differences in temperature, water seeping through, and so on, cracks the sandstone. So you have to, it's not a good material for the long, long run. Granite is a lot better for that. Okay. So All right. Well, thank you very, very much. I hope that this has been helpful. I hope also that you were able to see a little bit more about the process of how to use these links and these materials in order to learn and understand that it's fine if you don't understand 100% of everything. Okay? The important thing is to know what you do know and to know what you don't know. Okay, so that is how learning happens, and you need to be kind of your own monitor of your own learning. Does that make sense? Okay, so let's finish with a prayer. And Sabrina, do you have a mic there?
Yes, yes, it does.
Mm-hmm. Okay. Anyone that has a mic that could offer a prayer and would be okay. Sabrina, go ahead. Mm-hmm. Thank you.
Can you hear me?
Yes, we can. Mm-hmm.
Heavenly Father, we're thankful for this day, and we're thankful for the lesson and the time that we had to learn, and please help us to remember it, and in the name of Jesus Christ, amen. Amen.
Amen. Thank you very, very much. So Annika and Rodney are kind of linked together there in the thought process. That's good. Okay, amen, and thank you, thank you.